Source. Yep.
I don't know if you can see my screen as well. I'm sharing just a window with the documentation just to talk about that.
Yeah. I was definitely looking at this yesterday or the day before with some examples that were helpful for some of the things.
Yeah, I've been using it a lot as a reference anytime I run stuff. So for the most part, I think it's like super helpful. I think the second level is a bit light right now, but I think that's just because it's work in progress.
Right. The documentation for the second level is a little bit of a work in progress. So I try to put as much information in there as possible, but there's still a lot of things that are not very well explained. So, my plan is just to briefly go over the documentation, just to explain what the second level analysis actually do and how they are organized, and then if you want, we can just jump ahead with your questions and your examples, and we can go over those in a little bit more detail to make sure that everything is working as you would expect, and any questions that you might have are all answered. Does it make sense? Sounds good?
Yeah, sounds good.
Do you want to get started, or are we waiting for somebody else?
No, everyone's here.
Okay. Okay, so the second level analysis was kind of like the last stone on the Frank Lab pipeline, that organization. We had the way to import DICOM data, do all the pre-processing of the functional and anatomical data, then running first level analysis where we do the model estimation for a number of things like including parametric modulation and this type of complex things. And then we have with those data, which are basically all of that I had just said, is basically done at the level of individual subjects. We can even run it parallel because you can just process each subject separately, and you will end up with a file that represents some beta image that corresponds to the, I don't know, speech minus baseline contrast for one particular subject for one particular condition. But then when you want to aggregate across multiple subjects, then this is the place where you run second level analysis to do any type of population level inference. So you want to know whether the subjects that you are getting in your experiment from the data from those subjects, can you extrapolate to what is happening in the population where these subjects are being drawn from? And this is what the second level analysis is actually doing. It follows kind of like the same logic as in terms of syntax of how everything is run. You have these sort of config files, CFG files, where you specify all of the information for the preprocessing analysis and for running first level analysis. So now you also have these configuration files for specifying what type of second level analysis you want to do, and also the syntax for calling FL commands is also the same. You have this type of FL import to import. Oh, by the way, I used to call this FL underscore basic. I just changed that, and now it's called just FL, just to make all the syntax simpler and the lines shorter. So you can still call FL basic. It will work. It will just call. It's just a wrapper now to basic FL. Okay, so you have FL import the data, FL preprocessing to run preprocessing, and you specify the individual subject in the pipeline. You have FL first level to run in first level analysis, and you specify the subject and the preprocessing pipeline, and then the model, the particular first level analysis model that you want to run. And now you also have FL second level where you specify, sorry, this is wrong. This is, I think we are calling it study ID. So you specify instead of individual subject a study ID, and then you specify also the preprocessing pipeline, the model ID, which corresponds to the first level analysis model that you have run, and then you specify a second level results or analysis ID, which corresponds to the type of second level analysis that you want to run. So basically the logic of the syntax is pretty much the same, only that instead of working on individual subject, now it works on entire studies, right? So you don't specify individual subjects at this level, you just specify the study that you want to run, which particular pipeline you want to enter into your second level analysis, and what particular first level analysis you want to taken to the second level, and then you specify with the results ID, you're going to create a configuration file where you specify the details of what type of second level analysis you want to run. So let me go, let's see, back here. So this is the syntax in general, how it works. It has these four fields, the study idea, and this is just an example of how it will work. In the example, example would be a name of a study. In this case, we have like in our studies, we have like sick PDS or something like that. Just remember that the subject IDs always have some root, which was the name of the study, and then some number, and then something else. While the study ID is basically that root that is part of every subject ID. Right? And then you specify the name of the preprocessing pipeline. This is the same as we were using before when you specify the FL preprocessing step. Then the name of the particular first level analysis that you run, and this is the same that you use when you run FL first level. And then you specify a new name that is the name of the ID of your second level analysis. And as before, when you specify a name here, that corresponds to a particular configuration file, right? So when we have fMRI space in here and you run preprocessing, you expect to have something that is called preprocessing_MNI space.cfg that contains the details of what the MNI space pipeline is. And when you enter here something that is called speech, and you run first level analysis in the Frank Lab pipeline, you expect to have something that is called first level _ speech.cfg, and this is a file where you specify what this particular model ID is all about. So the same thing happens now with the second level analysis. When you have you specify average here, you expect to have in the config directory also a file that is called second level _ average.cfg that specifies the details of this particular second level analysis that you want to run. And the reason why we are doing it this way and keeping a configuration file, in case you're wondering, because many of these models, it would seem like a little bit of a waste to have to create a configuration file for running something that is just a second level analysis that might be just specified with a single command with a few more additional parameters. But we are trying to keep everything in a configuration files because that helps us keep track of what is happening and all of the analysis that you've run. We have a very nice record of what they are. And if you ever wonder and go back in a couple of years to this study and you are wondering how you actually run this second level analysis, you will have the configuration file that allows you to repeat that analysis and will tell you all the details of what went on that particular analysis that you run. Okay, so is it clear so far? This looks reasonable. Do you have any questions? No questions? Okay, so the details of this configuration file this is just an example. It's relatively simple, and I try to simplify it even further than what it was a few days ago. So basically, you just specify something that is specify the individual conditions that you want to enter, and this is either one condition or multiple conditions. Those are the conditions are defined, if you recall, when you run first level analysis, right? You run the first level analysis and you specify some particular conditions that you want to look at, and those would be individual speech minus baseline activation type of things, or contrast between different speech conditions, or things like that. Those are the individual conditions that are defined at the level of the first level analysis. So in here, you just have to give the name of those conditions, and you can enter one or multiple ones. When you have just one particular condition that you care about, that you want to look at the average, for example, like a two-sample t-test, you just specify which particular condition you want to enter in here after the conditions field. If you have multiple ones because you want to do a contrast between conditions, you can also do that, just specifying more than one condition here. You could enter 2, 3, whatever number of conditions have already been defined for that particular first level analysis, and enter them here and enter all of those conditions like in a repeated measure type of analysis for second level analysis in your second level analysis. So that happens for, I don't know, when you have like a longitudinal study and you want to look at before and after. So, and then you want to contrast the two of them. You will have a condition that is called before and a condition that is called after, and then you will look at the difference between the two of them. So those are the conditions, basically just listing whatever conditions you want to pull into your second level analysis. Then you specify the design, and the design is, I don't know if you recall, many weeks, probably months ago, I gave a little talk about second level analysis in general, right? The GLM, and I was talking about the design matrix and how you do specify within subject contrast and between subject contrast. Do you recall any of that, at least vaguely? Okay, so this is basically the design. Is basically the design matrix. I don't know. Well, that I think we have it in some of our videos, right? And we should have that particular talk. So that's kind of like the logic of how a second level analysis is specified. And just a very brief overview of what we talk about there is that in order to specify a second level analysis, you have to specify four things. You specify the actual data that you want to enter. If you have one or multiple conditions, you specify which conditions do you care about. That's basically the columns of the Y matrix, if you recall that from the talk. And then you specify the columns of your X matrix. The X matrix was the design matrix, right? And you have to specify what are the columns of those X matrix which are going to act as your effects of interest that you're going to try to model across subjects. And you can have just a simple column, just a design matrix, which is a single column of all ones. That would be like when you're just trying to model like average effects across a population, or you can have multiple columns when you have a more complex second level design, right? That was the second thing that you have to specify. And then you have to specify the contrast across all of the columns of the Y matrix, which was your data. The columns of the Y matrix were the conditions. So you have to specify this color between conditions contrast or within subject contrast. Basically, when you enter multiple conditions, what is the particular contrast that you care about across all of those multiple conditions? And you have to do the same thing for the X matrix. If you have multiple columns in your design matrix, you have to specify what is the contrast that you care about across those different columns. If you enter something like, for example, here, you enter all subjects and age, that specifies that you have two columns in your design matrix. The first column is this particular keyword that is all subjects, that is basically referring to a column of all just ones. And the second is age, which is going to be, I'm going to show you how to specify age, but it's going to be a column that contains the age of your subjects. And then you have a design matrix with two columns. The third thing that you have to specify is a contrast across those two columns. What do you care about? Those two effects. And in here is where you specify the between subject contrast within, and you specify this contrast vector, which is just saying that I care about the age covariate. So basically, this is just this analysis specified through these three fields, and is saying that you want to enter the speech minus baseline contrast data into your second level analysis. You want to model it by two factors. One is a column of all ones, which is the constant term, and the second is a column containing the actual age of your subjects. And then you're going to look at contrast across those two things, that is 0, 1. So basically, you're going to look at just the age effect. So this is doing a correlation between your functional activation, basically, and age. You are asking the question of whether is the speech minus baseline effect size, so basically the amount of activation, larger for older subjects compared to younger subjects, or vice versa. So you're doing a correlation between activation and age. This is how you specify in your second level analysis.
And presumably there could be something like group that would go there.
Sorry, I didn't quite hear it. Could you repeat it?
Would group go there if you had?
Right, exactly. And if you have like two groups, for example, you have a patients and controls, you would specify a design matrix that has two columns, two effects. One is called patients and another is controls. And then when you specify the contrast between, you say if you want to compare the two of them, you would enter a contrast of 1 minus 1 to specify that you care about the difference between the patients and controls. And this is all in line with that other presentation where we talk about the design matrix and how to specify a few contrasts and how to remember that 1 minus 1 to look at the difference between two effects or the difference between two conditions or things like that. You have, so basically those are the particular contrasts that the typical contrast look like everything is 0 and a 1, or something that looks like a 1 minus 1, and then it may have additional zeros. So for example, if you have two patients and controls, two populations, right? And you want to look at the difference, you would enter just patient controls and then 1 minus 1. But if you want to also do the same thing while controlling for some particular covariate, like for example, age. So you want to look at the difference between patients and controls, discounting any difference that may be accounted for by the difference in age between those two groups. So the way to do that would be to specify 3 elements into your design. You would enter patients, controls, and age, and then you would enter a contrast between that is just asking the difference between the two of them. So it's 1 minus 1, 0. That's a way to look at the difference between patients and control while controlling for the effect of age, for example. Does this all ring a bell? Are you familiar with this, or do you want me to go back to that original talk and go into all of this in a little bit more detail?
I don't know. I don't know. I think it would be good to circle back. Maybe we could just go through what this is supposed to look like. But my next question, if we just put aside the idea of circling back, is
okay.
Can we just look at an example of what these are? So, are you actually listing vectors in this file, or are you have some file that has
Right.
different
Right.
various columns?
Right, that's a good question, and you have actually the two options, but I'm encouraging you to use this option. So this is an actual file. You could use this file, and you typically just specify the actual label of the columns that you want to enter into your design matrix, and then you have a different file where you actually specify all of those covariates. But it's actually possible to enter here the actual age values. Instead of enter age, you could enter, I don't know, if you have 10 subjects in this study, you could enter 10 numbers that actually correspond to the 10 values of age for those subjects. But I think it's better to keep that separate into a single file that contains all of the covariate information for your subjects, rather than entering those in the configuration file for individual subjects, because that is prone to errors and duplication of data and all of those issues.
That makes sense. So you'd have some other file. Would it have multiple columns, or is it just a file with one column?
Right. So there is another file that is called, let me see, what is this specify? I don't have it in here.
I can open an example if that would be helpful.
Right. Well, yes, I have an example here as well, so I can go through that. That's fine. I just wanted to see if I was actually describing it in the documentation there, but I wasn't. It was probably a little bit further up. So let me see. The details of the configuration file is in here in this. Let me see. Oh, no, this is actually the example. No, let me go at details of the second level first. Second level. Okay, so this is where it specifies the actual details of the configuration file. When you enter the configuration file, I just show you a very brief example, but this is where it is specified all of the things that you can specify there. You specify a conditions field with a list of conditions, a design field.
For one question here.
Sorry, go ahead.
Is the use of the term conditions here, does that signify something other than a list of contrasts that we're finding?
Right. It's what we call contrast in the first level, but I didn't want to confuse what we are calling contrast here at the second level with what we are calling contrast at the first level. So I call it conditions because it's, I don't know, do you have a better name? We can use whatever better name you can think of.
Well, let's think about it, because conditions is also somewhat confusing, because the idea is that you're specifying a contrast between conditions there.
Right, but this contrast is between conditions. This is perfectly fine. I mean, what I don't want to confuse is what we call, remember here where you specify the first level model, you can enter actually, where was it? I don't have it here, an example. Where was it? I should have it here.
I think the examples below. The whole list.
Yeah, this contrast basically. Remember when you specify the first level analysis that you can specify, you actually specify there the type of contrast that you want to look at. If you have like a speech condition defined and a baseline condition, you specify a contrast across those effects. It's called like and you call it like a speech minus baseline, and that is a contrast, right? Those are the first level contrasts. Whatever names you actually enter here, those are the actual names that you want to enter here. So if you want me to change this from conditions to something else, that's perfectly straightforward to do. So just let me know what name you think might be a little bit more meaningful.
I get Jason's point, because I had the same, when I first looked at it, contrast would have been more intuitive to me, and I can see why that's confusing with the between and within, but maybe contrast names.
Okay, so perhaps I can call this, so perhaps we can call it contrast, just in the same way that we call this contrast, because it actually refers to the same thing. And then, let me see, just to keep track of what I'm doing, I'll go back and actually make sense of this.
Contrast underscore names.
Contrast underscore names, something like this. Okay, and this, we can call it like contrast vector, or is it fine to keep it like this, contrast between, contrast within? Because these are basically a list of names of the contrast that you care about, and these are actually numbers, right? Either a matrix or a vector that actually contains the contrast vector that you want to enter across the multiple either effects or, I don't know.
I think the names are fine. I think it's maybe just more of a description in the FL Basic, in the Frank Lab document.
Right. Right. Okay. So I'll work on making the description a little bit more thorough. But the idea is this. I know is this contrast is basically this contrast. Whatever you specify here, whatever contrast you have defined at this level, you gave it a name, right? And you then specify some particular vector that specifies how that contrast come to be whatever name you gave it. So those names are the things that you are listing here at this level. So after let me just keep it as it was first. And I'll think of alternative names later. After the conditions field, you enter basically a list of contrasts. Whatever first level contrast, we can call it perhaps first level contrast or something like that.
And is there now a sample an example second level analysis file in the example directory? I don't think there was like a week ago, but there might be now.
You mean this particular file, the second level average, is not there?
Maybe it is now. I just wasn't when I checked a week ago.
Maybe I didn't copy it because I have to. I typically just copy M files, so perhaps I forgot to copy configuration files. It might perfectly be. I'll put it in there. It basically should be this thing in the bottom here. These two files, the second level average, basically should look like this, and second level correlation should look like this. If these files are not there, I'll put them there. And they are just examples of how these things should look, basically. But and again, this is up to change. I may change these names to make it a little bit more meaningful. But yes, but to answer the question, what I was the things that you enter here are the particular contrast that you define at the first level of your analysis. So if you created a contrast for fast speech and a contrast for regular speech, then you would enter fast and regular, whatever names you gave them in here. And in here, when you specify the contrast, this corresponds to what we call the within subject and the between subject contrast when in the GLM talk. Remember that we talk about 4 things that you need to specify. You need to specify the columns of Y, the columns of X, and then the contrast across the columns of X and the columns of Y. Those 2 contrasts are the things that we are specifying here. So basically, this is when you have a model like, let me see, like this. So imagine something like, let me make it a little different, just to so that it's clear what this is about. Let's say we have fast and slow minus baseline, and then regular minus baseline. And you define all of these at the first level, right? So these are 3 contrasts that you specify, and you want to look at a combination of those 3. So basically, the contrast within is always a vector or a matrix that has as many elements as whatever things you're listing here. So if you are listing 3 conditions here, you should have 3 values here. You can enter, for example, something like, I don't know, 1/3, to specify just the average of these 3 conditions. And then whatever number of things you enter here in the design is the number of elements that you specify here. So you enter 2 things in here, you have to specify a contrast vector with at least 2 elements, or a contrast matrix with at least 2 columns. So perhaps I can make the names a little bit more, to specify a little bit more clearly this association, because this particular contrast corresponds to a contrast across the columns of this design matrix, so basically whatever you specify here. And this particular contrast is a contrast across the columns of the data matrix, which is whatever you specify here. So in a sense, this contrast applies to this thing, and this contrast applies to this thing. Does this make sense? Okay, so if you have any suggestions for how to rename this, I'm perfectly happy. And if you want to think about this and let me know later with an email, just send me an email and let me know what type of consensus or ideas about potential ways of making this, naming this a little bit more intuitive. But does it make sense in terms of what all of these fields mean so far?
I just have one small question. So for both of these, like contrast between and contrast within, do they always equal to 1?
That's a good question. Right. There's a rule of thumb that typically the positive numbers in a contrast vector are up to 1, and the negative numbers, if any, they are up to 1 as well. But that's just a rule of thumb just to keep the effect sizes meaningful. So basically, when they are up to 1, you can always interpret the effect sizes of the resulting beta matrix or contrast vectors for this second level analysis in terms of averages. That's why they are up to 1. So basically, if you do a contrast vector like this, basically then the numbers that you get for effect sizes at the second level, they can be interpreted as the average of the activation across these 3 conditions. If instead of that you enter in here 1, 1, 1, that's perfectly fine. The statistics are going to be the same. The cluster level statistics are going to be the same. P-values are the same. Everything is the same except effect sizes. If you look at the effect sizes within a cluster and you interpret those numbers are the sum of the activation across these 3 conditions instead of the average. So it makes interpretation of effect sizes a little bit more difficult. So the rule of thumb is typically when you specify this contrast, you want to scale them so that the sum of the positive numbers are up to 1 and the sum of the positives are up, negatives are up to -1. But that's just a rule of thumb to make the interpretation easier. The actual statistics are a scaling variant. Whatever, you can multiply this whole thing by 2 and the statistics will be the same. You will get the same t-statistics maps and p-values and cluster level statistics, and everything will be exactly the same. It's only effect sizes will change. Yes. And you can also specify a vector, right? So if for example, you want to look at what is happening, is there age correlated with activation in any of these 3 conditions instead of the average of the conditions or any one of those individual conditions? You want to look at whether activation is correlated with age in any of the conditions. You specify a contrast matrix, basically. And contrast matrix is just like a contrast vector, but you have multiple rows. And the interpretation is that when you have multiple rows, is that you get the results of whatever you're specifying here or here or here. So basically, this is looking at whether the first condition correlates with age. If you just enter this contrast vector, it will be looking at whether the second condition correlates with age, and this would be looking at whether the third condition correlates with age. So when you entering all of them into a contrast matrix, you are just asking the question of whether any of the 3, so the first or the second or the third, are actually correlated with age. So this is a way to do what some people call it a conjunction, but it's not really like a regular conjunction. This is it's I don't know, in SPM literature they call it a global null conjunction, I think. Yeah, instead of conjunction null. So they call it global null. It's a weird name. It's just like an OR question. Basically, you are asking the question of whether the same question that you would ask by the individual contrast, only that you care about any of those things happening. In this case, is any of the conditions correlated with age.
The resulting activation here just tells you overall. It doesn't tell you specific to any one of those conditions.
Right. So when you do something like that, instead of getting a T statistics, you get an F statistics, and that is going to tell you whether that F statistic is telling you whether that particular voxel, any of these things are correlated with age, but it doesn't tell you the direction of any of them. It's not looking at the average whether these things are correlated with age in the same direction. It's just looking at whether any of them are correlated with age, no matter the directionality, no matter whether the average of them is actually correlated or not. So you just get an statistics that tells you whether that is true or not, and you typically then go back and look at individual conditions within the cluster that you care about to actually interpret what is happening in those conditions. Are you getting an F statistics for this particular analysis that is significant because one of the conditions were significant or because all of them were significant? And then you do this type of post-hoc analysis asking that question. Okay, so answering the question, I didn't even get to the question of Jason before. So basically, how do you specify all of these things, right? Because all subjects, I told you that was like a keyword, right? You can use all subjects without having to specify anything age. But age, how does the software know what age is about? So you always specify for those type of covariates, you specify everything. This is trying to follow a BITS convention for specifying all of these subject level covariates. And the BITS convention is that you specify all of that in a single file that is called this participants.tsv, and TSV stands for tab separated values. So basically, that is like it's a text file, but it's just separated by tabs, the different columns. So it can have multiple columns. Each individual column corresponds to one particular feature or of each subject, and each particular row is one particular subject. And the only rule is that you have to have at least one column that specify the actual subject ID. So this is called participant ID. So in participants TSV, it's going to be a file that looks like this. But instead of spaces, these are actually not space characters. They are actually tab characters because the different fields are separated by tabs. And you have columns that correspond to your variables, and you have rows that correspond to your subjects, and the first row are the names of the variables. And you always have to have at least this particular column that corresponds to the subject IDs, so that it knows basically this file specifies that for this particular subject, the age of this subject was 34, the sex was male, and the group was control, right? And you can just fill in all of your data in this single file that contains all of your variables of interest for all of your subjects. Sorry, go ahead.
Two questions. Do you need to have the same number of participants in this file as you do in your subjects, like your specific that you're specifying in your hash subjects, the second level design?
Right. I'm kind of struggling to figure out the best answer to that. And my impression is that we should try to force ourselves to actually, the answer to be yes, you need to have it, because I mean, right now the code has the flexibility to allow you not to do that, but I'm not totally sure whether that is a good idea or not, because I think it's good to force us to have basically every subject label. Even if that particular subject, you don't know that information, just enter it as missing data. But it's going to create a confusing situation if you have subjects that are actually processed and you have actual data for them, but you don't know where their covariates are and they are not listed in these files. I don't know. But I mean, I could go either way. We could allow that to happen. What do you guys think?
I don't know if this is exactly what you're getting at, but I can imagine we're in a meeting, somebody's run a ton of different kinds of analyses, and then someone makes a great suggestion of, well, just drop that subject. How easy is it to do that? To just like drop a subject, just rerun the second level without that subject? Can you?
Yes, I mean, if you decide, I mean, there are different ways to drop a subject. If you want to drop a subject as in let's make it as if this subject never existed and actually delete the data for this subject and actually delete it from all of our second level analysis, then yes, you could do that and actually delete all of the folders for that subject and delete it from this participant TSV file. But I don't think that is, I mean, I don't see many cases where that might be a good idea. I think it makes a little bit more sense to delete a subject in the sense that, well, you don't want to enter that particular subject into your second level analysis. You still want to have record of what happened to that subject. You actually want to still have the record of who that subject was and what was his data, but you just don't want to enter it into your second level analysis. And for that, you can just enter an additional covariate that have like the valid subjects, for example. Instead of having like a group, you can define a group with the subjects that you actually want to enter into your analysis. And you can enter a new covariate here, which is, I don't know, valid. And then you can enter just a 1 and 1 and a 0 for the one that you want to remove, for example. And you could define a group with the subjects that you actually want to enter into your second level analysis. And that would be a little bit more, I mean, you can run the analysis then, instead of entering all subjects, you enter valid as a covariate, and that will run the analysis only on that subset of subjects. And I think that is a little bit, I don't know, in my mind, at least it makes a little bit more sense in terms of data storage and making sure that we actually keep the data for that subject without having to delete anything. What do you guys think?
I got this to run the other like yesterday, and so there's the one subject that I included in all the first level analyses, but I said no, I don't want them. There's like weird stuff going on, so I just put NA in.
Right, that makes sense. Yep. Or you can just, I mean, instead of actually, if I had it some case like that, I would enter like NA here basically, because then when you enter valid in your analysis, it's going to remove that subject, but you still want to actually know what these values were for that subject in case you want to do something at some point and say, well, perhaps my bad subjects are the youngest one, or because they moved a lot, and you still want to keep these covariates. I mean, without having to actually enter. Well, deleting that value by entering missing values for that part in those fields, right? So basically just enter, do something like that, and then change, instead of entering all subjects, enter valid, and that will be the same. So if, for example, in here, I do this, then my analysis will only include these guys. It will not include this guy, even if it has the information of age for that subject, because that is going to be treated as a missing value for the valid covariate. So this analysis will be doing exactly the same. I'm looking at the correlation with age, only that I want to do it across only the valid subjects, what I'm calling valid here, instead of across all subjects. Make sense?
Yeah,
Yeah.
that makes sense.
And I think that is this is only my impression. I think this is it's going to be a more robust approach as to how to keep things organized for us. But I'm still not 100% sure. I can take suggestions, or what do you guys think? I mean, can you think of better approaches to try to keep the data and dealing with these cases where we want to remove subjects from some particular analysis but not others? Or what do you guys think?
I like this valid, not valid approach.
How would you specify that if you were still wanting to?
Sorry, I didn't hear it. Could you repeat it?
How would you specify that if you still wanted to?
If you still want that subject again, you could either enter here all subjects back again, or you could just change it here and enter a 1 for that particular subject.
Well,
instead of
if you wanted to do a contrast between the control and the patient group, that in either group you have a subject that you want to exclude from.
Right, that is fine, right? You mean if you have something like that, let me see. So if you have another patient here that has, I don't know, 7, and there's also a patient and it's male, something like this, you mean?
Yeah.
Right, if let's say that we want to do, that will work perfectly fine. I mean, oh, right, I see what you mean. If you want to do patients.
Right,
well,
everyone's in the valid group.
Right, but, right, well, this, okay, the way that would work, let me first answer the question and then offer alternatives. The way that would work would be doing this valid and then patient and then looked at. So basically this, no, sorry, group is called, right? It's called group, not patients group. So if you enter that, basically you are looking at the difference between patients and controls only within valid subjects, and that will work perfectly fine. The only trick with that might be confusing is that when I talk about group comparisons, typically when I did, at least at the other presentation, we're looking at the GLM, instead of doing this thing where you define a group that has 2 values, controls and patients, you could also have done something like this. You could have say, I don't know if this is going to confuse you, but I'm going to show you an alternative. You could say controls and patients, sorry, and enter 2 covariates, and then you enter 1 and 0, and then you enter here 1 and 0, and then you enter here 0 and 1, and then you enter 0 and 1. Okay, so if you have this case instead of the other case, then typically when you want to enter all of the subjects, you would do something like this. You would do controls and patients, and then enter a contrast 1 minus 1, right? This would be a typical contrast for looking at the difference between controls and patients when you have this type of covariates. The results are exactly the same as what I did before, which is just having one covariate that encodes both patients and controls and entering the all subjects and that covariate. It's only that this is a different way to encode the same type of second level analysis. Well, okay, when you have this scenario, if you do that, then it will include all of the subjects. So one way to include only the subjects that you care about is just to enter valid in here and enter a 0 here. This might not be intuitive, but this just works. This is going to give you exactly the same contrast between patients and controls, only that within valids themselves. Okay. Does this answer the question? Is this what you were asking, or?
Yeah.
Yeah.
That makes sense.
Okay.
Is there something valid is there because of where it is in the order?
No, the order is just
part of the valid.
No, if you list it right, that's perfectly fine. No, if you list it in here, that will be so right. I mean, these are basically the contrast across whatever you specify up here in the same order as you specified up there, right? So if I enter valid at the end, the corresponding 0, I have to put it at the end of the contrast, right? Because this number corresponds to the first thing in the design matrix, this is to the second, and this is to the third. In the same way that when you specify here a contrast, right? And I was looking at, I don't know, let's do something like that, 1/2 and 1/2. If I do something like this, I'm looking at the difference between the average of fast and regular compared to slow, right? Because and this order of things is basically the same order as you specify here in the conditions. So the same thing happens in the design matrix. Whatever order you specify the elements in the design is the same order as you specify the numbers in the contrast vector. Make sense? Was this the question, or was it something else, Jason? Sorry.
It's just
Did the NA
part of it. Does the NA mean something?
Oh, NA is missing. It's not available, I think,
right,
or not.
So I guess it just drops that subject. So if you actually in the design you specify some vector, so whatever something, and you say I care about this basically. It's going to look through, and it's like if you had a 0 there instead of an NA.
Right, it's not the same. So NA is encoded as a missing value. So basically it means that that data is actually missing, and it means that when you enter a covariate that has a missing value for one subject, that subject is totally removed from the second level analysis. So for example, let's say that we don't care about, let's forget about valid and non-valid. Let's say that we just don't know the actual age of this subject. We have something like this. If I do an analysis that is just looking at the, I don't know, all subjects and age, and I'm looking at a contrast, I just want to do the same thing as we were doing before, right? I just want to look at the correlation between activation and age. I do the same contrast, but it just happens that this subject, I don't know the age of that subject. So basically, when you enter this into the second level analysis, it's going to run the analysis, but excluding this particular subject, because it doesn't know his age, it cannot be entered into this particular analysis. So NA is a missing value, and all missing subject, all subjects with missing data are removed list-wise from the analysis, from this particular analysis. I mean, from whatever analysis, well, to be explicit, any subject with missing data is removed from any particular second level analysis which includes or needs that particular missing data, right? So if I do something like this, the subject 3 is going to be removed from this analysis. But if I'm looking at patients minus controls here, because I'm looking at this and a contrast like that, this contrast is going to include that particular subject, because for that particular, those covariates don't have a missing value for that subject. So this subject is going to be included into this particular analysis, but it's not going to be included into the correlation with age, because you don't know age for that subject. Make sense?
Yes, and we keep rewriting things. Is that
right?
Because is there a way to basically pop out more than one second level analysis from this with a single configuration file, or basically if you want to look at, say, like you want to look at with age correlation, or I'll also want to just look at the group differences in each of these individual conditions or contrasts that are listed here. You have to have a different configuration file for each of those.
Yeah, you need to have a different configuration file for every second level analysis. That I just keep rewriting this for example purposes, but in practice, you want to keep a separate configuration file for every particular analysis that you want to run. What if you want
to do that very simple thing, which is, I want to look at second level. I want to look at, say you have 3 different contrasts that you're looking at. But these 3, say, and you just want to look at over all the subjects, and then the contrast of the two groups. You have to have 2 different. Well, actually, so let's take it back. What if you just want to look at 3 contrasts? All the ones that you're interested in this case, and you just want to look at the group difference for each. Is that 3 configuration files?
Right. I would create basically 3 configuration files, each of them being something like this, and then you just change the condition name for each of those 3 files. I mean, is it true that you could actually do that? You could keep this basically and specify a contrast vector like this. Oops, sorry, not that. Right. You could specify this. And then that will create a single analysis that runs an F-test. And then you can, I don't know if you're familiar with SPM. When you run SPM results, you can actually create new contrasts right at the second level analysis. For one particular second level analysis, you can specify additional contrast for that already run second level analysis. So you could actually do this and then specify manually like 3 different contrasts for this within the SPM GUI and see the results for each of these individual things. But I don't think it's a great idea. I think it's the best idea. The best idea is to have different configuration files for everything, because that is going to help us keep track of what each particular analysis is going to contain, basically. Because for every configuration file that you define, there is going to be a folder that contains those second level results, right? And we want to make sure that we have a record that tells us what created that folder, basically what type of analysis we ran that actually resulted in that folder creation. So there's a one-to-one relationship between these names here and the folders that are going to exist in our database, basically. So I think it's best to just basically keep a different configuration file for everything, for every different analysis that you want to run. So, I don't know. Again, what do you think? Do you think it makes it's better to keep one configuration file for multiple type of conditions and then allow, I don't know, having all of them in a single folder, just allow multiple conditions at the second level on that?
I think the way it's already set up makes a lot of sense, because if you had a configuration file for different groupings of analyses, then
Right.
like you could theoretically have just like separate groupings, but the groupings don't necessarily mean anything differently. The only thing you care about are the individual concepts, the individual analysis that you're doing.
Right, and also these things can be kind of reduced a lot, right? Because the configuration file only for the second level analysis can be run for different first level analysis and for different preprocessing pipelines. You don't need to create different configuration files for that, because when you specify your syntax for running the analysis, you also have to specify basically which particular. Let me see if I can find that here. It should be here. Right. So when you run this results ID corresponds to one particular configuration file, but you can run that particular configuration file across multiple pipelines or across different first level analysis. So if you have created, I don't know, 4 variations of your first level analysis that have the same contrast names, you can still reduce your single configuration file. And if you have created multiple preprocessing pipelines, you can still reduce that particular configuration file. But it is always going to be like a one-to-one relationship between this configuration file name and a folder that is going to appear within this particular subfolder that corresponds to the derivative subfolder. So I don't know, it's not specified here, but within the derivative subfolder, there is a results subfolder that then contains the name of your particular, for every preprocessing pipeline, you have a subfolder, and for every first level analysis, you have a different subfolder, and then for every second level analysis, you have a different subfolder within at the end of there. So there is a one-to-one relationship between folder names for preprocessing pipelines and folder names here, folder names for first level analysis and folder names here, and folder names for second level analysis and folder names, well, one level down there for the second level analysis. So what I'm trying to say here is that even though it seems like a lot of work to create multiple configuration files for this second level analysis, you're going to be reducing a lot of these configuration files all the time.
I think it also,
I don't know.
If you wanted to add another analysis into it, just another second level analysis, you wouldn't have to run all the analyses together. You could just run that new second level analysis. So like, oh, actually we want to look at the interaction between these two conditions, between the two groups, but that's not already specified. You could add it to your previous one, and then you'd have to run all of those analyses again. Or you could just create a new configuration file that runs a new analysis.
Right. If you do you mean like adding an additional condition at your first level analysis, or are you referring to adding a new condition at the second level analysis?
No, I'm saying adding a new condition, adding a new second level analysis, a new, like, let's say you run a speech minus baseline across all subjects. So just very simple, just like the one that's written here. Mm-hmm. And then you decide, oh, I want to run a correlation analysis with age. Well, if you could add in age to this file and then, have some way of putting both of those analyses in this one configuration file, then you'd have to run both analyses over.
Right. I see what you mean. Right. And well, if you keep it as a separate file, then you can always, just run that particular second level analysis without having to care about other analysis that you may have included into the same package, so to speak. And there are also like practical reasons why this is better. SPM has the approach of allowing you, to specify multiple contrasts for the same first level analysis, but that creates some complications for, this is going to be too technical. So to make it brief, basically is simplest or more straightforward to make sure that your second level analysis is run and defined correctly, particularly in the context of repeated measures analysis and things like longitudinal analysis and things like that. When you keep when you create basically a different analysis for every particular contrast that you care about, because in some cases, by trying to pack multiple contrasts into the same analysis, you end up having an error in how you specify the analysis. This, I'm not going to get into the details. I'm just going to say that technically, this is a little bit more of a more robust approach also to making sure that your second analysis is always correctly defined. Okay, so coming back to the participants TSP, does it make sense? I know that you guys had questions about this, how do you specify different control groups and things like that. Do you have any, is that clear now, or do you want me to go into, do you have any particular questions that you want to go?
Question, based on how you had it originally set up with group, like a variable for group and then control of patients.
Right.
If you had it that way, how would you then, under design, specify a patient control contrast?
Right. So I think it was control patient. So something like this, right?
Right.
Right. So well, just as an internal thing, this typically you don't need to know this, but when you, just for the sake of being explicit, when you enter this is exactly the same as entering once for the controls and two for the patients. So basically the way that internally FrankLab, our scripts are going to deal with these names basically is to convert them to numbers, and it's going to convert them in alphabetical order. So wherever these things, names are going to be converted to actual numbers, and the controls are going to be looking at like a 1 in your design matrix, and the patients are going to be looking at a 2 in your design matrix. So when you want to do the patients minus control, the difference between patients and controls, when you have this type of definition, you do that by doing this. You enter here all subjects or valids, if you just care about valids, and then, how was it called? It was called group, right? So group, and then the contrast is 0, 1. So basically, this is how you test the difference between the two groups in this particular way of specifying those two groups. I mean, this sometimes makes a little bit more sense if you think of this as, I don't know, like gender, for example, in here. And you also specify gender as a variable that is, it has 2 levels. It's males and females. So F is going to be 1 and males is going to be 2. So if you enter something like all subjects, sex, and then 0, 1, you're basically looking at the gender effects, right? In terms of like, if you think of this as an ANOVA, you're looking at the gender effects in this particular model. You're looking at the, if you have age here, you're looking at the age effects, right? So you're looking at correlation with age. When you enter a gender here, you're looking at gender effects. So it cannot make sense in that way of specifying contrast. So individual categorical variables that only have 2 levels, so basically 2 groups, they work exactly the same way, at least kind of like in practical sense of how you specify the design matrix and the contrast as continuous covariates. You can treat them typically in the same way. When you have more than 2 groups, they don't work in the same way, because if you have more than 2 groups here, you have patients, controls, and family or something like that, then you it's best to specify as 3 different groups instead of 1 single group covariate with 3 variables, because when you do it like this and you specify 3 levels of a categorical covariate, it assumes that the levels are sorted, right? And you do that when you have ordinal categorical variables where the order matters. But typically when you have groups, you don't care about the order of those groups. You think of them as nominal categorical variables. And for that, it's basically best to dummy code them. But for those cases where you have groups and those groups have always only 2 levels, so basically it's a categorical value that is nominal but only has two values, then it's just the same to have a single variable or have 2 variables, 1 for each particular group.
Alfonso, kind of to that point, if you have 3 members of or 3 levels of a variable, is it treated as ordinal or is it treated as a like continuous?
It's going to treat it as ordinal in the sense that this is going to be converted to 1s, 2s, and 3s if you have 3 levels. So that is not the typical way that you want to deal with it. You typically want to have, if I have something like this, and yeah, oops, keeps doing this.
I would think that you would want,
severe.
you would not want to see if there's a general effect. I mean, you could see if there's an effect across levels.
Right. I mean, sometimes you think of them as different levels of the same kind of like continuous, and you are fine with thinking them as ordinal. Basically, that the difference between 1 and 2 is the same as the difference between 2 and 3. As you want to do, you see whether there's any general trend in the direction, like when you have like severe cases, right? And like that would be like a case where you might want to compare patients, control patients, and then you have like a more severe case of patients that have like high severity and you have low severity for this case. And sometimes you want to treat that as an ordinal variable, right? Where these are just 3 levels of some underlying construct. But in other cases, you would want to just, when you want to treat them as 3 categories that are not necessarily sorted in any meaningful way, then you typically want to have them as 3 variables there. You specify one variable that is called controls, then another one for the patients, non-severe, and another one for the severe patients, and just enter 1s and 0s for each one of those columns. Make sense?
Yeah, but you assume that if you have 3 different levels, it's going to try to fit a line to that. So it's going to assume that there's a linear relationship. It's not a linear relationship. Like if you expect there to be patient and patient severe much closer together, and control is very different than.
Right, yeah, you're totally right. Yes, if you enter them in here and they basically are converted to numbers, the difference between level 1 and 2 is assumed to be kind of like relatively similar to the difference between level 2 and 3, because the analysis is going to look at those 3 groups. It's going to put the first group at the 0, the second group at the 1, and the third group at the 3, and it's going to try to fit a line through these clouds of points at these 3 levels, right? So you are assuming that there is kind of like a little bit of a continuous gradation between 0 and 1 and 1 and 2. If the difference between 1 and 2 is much larger in terms of conceptually than the difference between 0 and 1, then you don't want to use this type of ordinal analysis.
Thanks.
I just have one more question about this. So let's say you're looking at sex effects and females are coded as 1 and males are coded as 2. Then when you get your results and you see increased activation, does that mean that there's increased activation for males or increased activation for females?
Right, that's a very good question. And that's where that detail that I told you might come handy, actually, because these are sorted alphabetically, and you are looking at the effect in the direction of like a positive contrast in here. You are like this. Then a positive number means that the ones with the M's have higher values than the ones with the F, right? Because the M's are going to be at the 2 and the F's are going to be at the 1. Then the positive numbers mean that the M's are higher than the F's, and in this case, males higher than females if you're looking at activation. So this is why, yeah, the knowing that in general, I recommend keeping groups as so instead of that, I would typically recommend like doing males and females and just enter 1, 0 for males, 0, 1 for females, 0, 1 for females, 1, 0 for males. And then when you do something like that, then you're looking, instead of that, you're looking at something like that. When you are looking at that, you can then actually enter here the contrast, and then by looking at the direction of that you specify this particular contrast, this is where it's going to tell you whether a positive means higher for females or higher for males. In this case, a positive means higher for females because you are assigning a 1 for females and a -1 for males, right? And if you do it the other way around and you enter something like that, then a positive means higher for males. Make sense? Okay. So yeah, when you want to look at the directionality of things, it's always good to keep track of these signs, basically how, and in case of doubt, just plot the effects for males, plot the effects for females, and figure out whether you are right in the way that you are interpreting the directionality of the effect. This becomes a little bit more complex to get the right interpretation when you have like when you have a design that is rather complex. In this case, the directionality of the effects becomes a little bit confusing to look when you're looking at the interaction, for example, and I don't know, let's say that we have young males, older males, young, females, older females, and then looking at a contrast. And we have these 4 groups, and then you're looking at the interaction between those 2 things. So you're looking at this, something like that. So now this is basically looking at whether the difference between males and females is different in young population versus older population. So that is an interaction between the gender effect and the age effect, right? In this case, but the directionality of this effect and figuring out whether a positive means that it's actually is actually higher activation in young males compared to older females, or what is it that we are looking at? That becomes a little bit confusing to make sure that you get it right. So in this case, it's the best. I mean, the moral of this is that when it's difficult to interpret the directionality of the effect, the best idea is just to plot it in each individual cluster and figure out the proper interpretation for plotting the activation in young males and older males, and then young females, and then older females, and looking at the effect. You found that the interaction was significant. Then do a post-hoc analysis looking at the individual effects for those 4 groups and figure out what it all means. Let me watch all subjects and group weight loss. Any other questions on how you specify this participants.tsv file? Or
just one small thing. Is it NA or N/A?
All right, I think this is bits and definition. I think it's N/A. You're right, but I'll check it up. I don't recall. I miss it. I say NaN as in what I'm missing numbers in MATLAB for not a number, but I'm not. That's not true. It's NA, but I always forget whether it's actually a slash or not. So, in case of doubt, look at this, which is the bits configuration. Bits format, and you can blame it on this. Look at the bits specification, and so I think it's N/A, right? Missing value should be coded as NA, so that's what it says. So NA is. And this is also where it specifies kind of like the format of tabular files and why they are this way. Well, anyway.
Oh, and one thing that I noticed with the participants.tsv file is that when I was editing it in MATLAB, even though I typed tab, it didn't actually add a tab, it added a couple spaces. So I had to edit it in another program.
That's a good point. I think you're totally right. I think this is a MATLAB thing. Let me check. I think there is a setting in the preferences where you specify something about the editor, whether tabs are converted to a space or not. Yeah, this is it. Like tab key inserts spaces. This thing is the culprit of all your pain. So if you just, that will be a tab. But this is difficult to know for programming in general, but I don't know. It's clear. If you want to use MATLAB, remember to uncheck this thing so that the tab is interpreted as an actual tab instead of multiple spaces. No problem.
If you were to create say like a MATLAB structure that just had this information, can you just then digital fields and just generate the TSV file from that?
Yes, there is a let me remember how it was called. I think it was right. No. There is either an SPM command for doing that or a conn command. I don't recall. I'll look it up. There is a command to converting that structure to the. Let me see. Get file. No. It's a conn read. Was it load text file? So sorry. This come on, coin. I see. So this kind of does the opposite. This reads this TSV file and converts it to a structure, And I think that was perhaps it's not in here. Let me see. Save text file. Yeah, context. That's the opposite. Basically, takes a structure and converts it to a text file.
Okay. Seems like that might be because a lot of the information you put in there could be like a vector array.
Right. So if I have
structure that can become handy anyway, then just generate the text file from that TSV file.
As long as it uses the types.
I think that's what's happening is you have just a structure.
right. So you have a structure like this, basically that contains many names, right, and a lot of values. You can just use the save text file to create a TSV with that. And the opposite thing, if you have a TSV file and you want to convert it to a structure in MATLAB like this, basically you can just use the load text file. This is also useful sometimes to check that your TSV file format is correct, or this is going to be interpreted correctly by MATLAB, and just try to read it directly, explicitly, and convert it to a struct, and see whether that happens, that conversion actually happens correctly. Okay, any other questions? Okay, so this is how to create second level analysis and run it. A couple of minor things that I didn't mention is basically that two additional things for second level analysis. When you run second level analysis, if you already run your second level analysis, you can use the syntax FL second level plot, and then specify the same things that you specified when you actually run the second level analysis to actually just display the results of your second level analysis. This is going to just bring the GUI display for your results, right? When you just want to plot an already completed analysis. And then you have also this thing that is when you run a second level analysis and you want to run it at the level of ROI level analysis for some particular ROIs that you have defined through an atlas or through multiple ROI files, you can also use this syntax, FL second level.ROI, then specify the same thing that you specify for your second level analysis, and then at the end add the parameter, the name of your ROI file. That could be either one or multiple files. It could be one file that has multiple, like an atlas file that has multiple ROIs defined. And the only restriction so far that I might try to change that in future versions, but restriction so far is that you have to make sure that this kind of like externally or at least manually, that this ROI file is defined in the same space as your whatever analysis that you have run. So if you have run, for example, surface level analysis, you need to specify a surface based ROI file. And if you have specify like volume level analysis, you have to in M&I space, then your ROI file should also be in M&I space and should be a volume based ROI file.
Which M&I template is FL running in?
Is using the MNI 152, I think well, it's SPM convention here, so it's using the SPM 12 preproc routine, so it's this dual normalization and segmentation routine, and it's using, I think that is fine-tuned to the MNI 152, although in practice it's not actually a template, right? Because they stopped, SPM 12 stopped using this normalization where you actually try to match your structural data to an actual template. And it now uses this combined segmentation and normalization where you actually tries to do the segmentation and the normalization in a single step. And the template is not a T1 file or a template of a structural file, it's a template of the different tissue classes. So you have all of these 6 different tissue classes that correspond to gray matter, white matter, CSF, air, bone, and soft tissue. And each of those tissue classes has its own probability distribution map of how it should look in M&I space, and then it tries to take your structural file into that space, and that procedure, I think, is fine-tuned to match M&I 152, but I don't know, to some degree it's not exactly the same as what it used to be, the M&I 152, because it no longer uses the template of that of the structural, the T1 file in that space to do the normalization.
So if I was creating various ROI masks, what space would I, as in, how would I?
Right, as long as it's M&I space, the difference between the different M&I kind of like variations is really minor. Just keep it as long as it's defined in M&I space, and if in doubt, use the M&I 152 space, which is kind of like the closest
That
one.
means that's the one created from 152 range, right?
Right. There was two variations. I don't know if Jason kind of like.
I 152 then, and SSL uses the same, so we might be able to.
Yeah, yeah, and all modern variations of M&I use slightly different procedures, right? Because they no longer use this kind of like a spatial warping technique to match like cross modality normal co-registration between your actual structural file or the functional file and your template. They use kind of like these more complex models, so they are no longer kind of like they follow the same logic that actually was used to define this M&I 152 space, because that use the kind of like older normalization techniques. So I don't know, to some degree it's not totally appropriate to still call it M&I 152, but it, I don't know. I think most people just use M&I to refer to one space, and they no longer care about kind of like the details of the minor difference between those different M&I implementations, whether it's FSL or SPM. Or
but if you're going to, so if you have ROIs and you derive from the structural scan, and you want to put them all in the same template, or you want to put them in some space, right?
Mm-hmm.
In some common space, it seems like the best option would be M152, because 152 and 305 are not the same. There are some differences.
Well, but you know, I mean, so in practice, if you have to find like an ROI with your structural data, you have the structural data, like the raw data, before any transformation of your subject, and you kind of like manually outline the region that you care about, and you want to use that ROI for second level analysis, you would still have to expect to transform that to M&I space, right? So you would have to apply the way you would do that typically is to apply the same transformation. So you take these y underscore something files that SPM created in the process of normalization, which was basically is encoding the transformation that SPM found to best match the transformation between the original structural file and M&I space, and apply that same transformation to your ROI file. And that would put.
So yeah, I guess that's what we're trying to say. You
right.
have this transformation, you apply that.
Yeah.
Right, you would apply the same file. I mean, you typically would apply the same transformation that you use on your original structural data. In this case, if you use FSL to do normalization, you would apply that transformation. If you use SPM to do that transformation, you would apply that transformation. Right. In this case, if you use this preprocessing pipeline in our FRANLab pipeline, then you would apply the y. You would use the y underscore something that nifty file that is created as part of the normalization step, and apply that transformation to convert your ROI file to M&I space.
So let's say, on a bigger picture here, now we're specifying the ROIs at the second level. Do we not have, so you don't do that at the first level, right? You do everything, you do either surface-based or voxel-based estimates, and then it's going to take those ROIs and it's going to extract the mean beta.
Exactly, yes.
ROI for each subject. And is that individual data stored though for each ROI? So if you want to do something like plot the ROI.
Yeah, definitely. When you run the second level ROI analysis, in addition to giving you like a little plot with the results, you also get like a mat file in the same folder. It's called rex.mat, and it basically contains all of the data for the individual subjects, right? And in addition to the statistics for the second level analysis and all of that. Yeah. And there are a couple of things that haven't been implemented yet that I'm working on that. And one of them is doing the subject-specific ROI file. So right now you have to specify an ROI file that is just a single ROI file across all of your subjects. But in some cases, we might want to use subject-specific ROIs. For example, what Jason was saying before, if you go to all of the trouble of manually delineating a region for every individual subject, you want to use those different ROIs for different subjects. So right now that is still not there, but it will be soon there as well, so that you can actually specify subject-specific ROIs as well.
I believe that except for this, some of the things that Elaine was going to test out, where we looked at subcortical ROIs that were derived from probabilistic atlas or from an MNI coordinate with a sphere. All the other things we're talking about are individual ROIs. So even you can make an argument that the ROIs. I remember, Alfonso, we had this conversation. I believe you were saying that you can make an argument that the ROIs that we get, like our cortical ROIs that we get using FreeSurfer, aren't really individual. But in that case, you'd have to have them all mapped via the FS average surface, right? So,
well,
that conversation.
Yeah, right. I mean, in terms of the surface level analysis, we kind of look at this some time ago, and we kind of decided that using a single file at the surface level in FS average space is pretty much almost exactly the same as using these subject-specific files in the original space of the data.
Well, unless you've corrected the ROIs for each individual subject.
Right. So yes, for those type of cases where you want to do like manual edits for individual subjects, or when you want to do actual manual definitions of the ROIs for individual subjects, is where you might want to have this type of like functionality to have subject-specific ROIs. But in most common scenarios, you would use the typical single ROI for across all subjects framework, which is what we have right now.
In most scenarios in this lab, though, we do the individual.
Yeah, I would say in most. So we need to, yeah. So I'm worried that, so for instance, we have this new DTI-based parcellation of the thalamus, for whatever it's worth. But that would be individual ROIs for each subject.
Yep.
And
I mean,
the thing that we have to kind of sort of mentally sort of get past for the cortical ROIs is, even if we say something like the ROI that we're using is this ROI label that's on the FreeSurfer FS average surface, but that thing does get mapped to each brain individually, so that if that ROI won't be like the same volume in each subject, it won't be the same surface area in each subject. It'll be different. You can say, well, it's the same because once you warp everything to the FS average space, it ends up, being the same patch on that surface. Still, once you map it back to the individual, will differ.
Right. I mean, that happens typically. That happens even in MNI space, right? You can define an ROI that is defined in MNI space, but then when that matches each individual subject anatomy, it's going to match at a slightly different location, because the transformation between MNI, the common MNI space, and the original raw subject-specific space is different for every individual subject. So, but that's not the type of subject-specific ROIs that I'm talking about. For all of those cases, there is still a single ROI file, because that is defined at the level of your second level analysis, which is basically either FS average space or MNI space. There are some additional cases where you might want to have subject-specific ROIs in the sense that they are not matched by any particular whole brain transformation. So there is not either MNI space conversion that matches your subject brain to one common space, or there is not the FS average convention that matches one subject brain to one common space. In some cases, you don't have that whole thing. You have something like thalamus, and you went and draw thalamus in this subject, and then you went and draw thalamus in this other subject, and then you went and draw thalamus in the third subject, and so forth. But you don't have a whole brain transformation. You don't have a space where thalamus is all matched into the same voxel so you don't have a common space. In those cases, you want to use subject-specific ROIs, because you want to extract that particular. Sorry, go ahead.
If we use the FreeSurfer subcortical ROIs, those are all subject-specific. Those are subject-specific segmentations.
Right, exactly.
We will, when we're doing these giant pooled analyses, we have gotten away from doing individual corrections. But when we do individual study analyses, we will often go in and edit some small number of ROIs on them.
Right. I mean, so yes. I mean, this is going to be there. should be soon enough. I mean, but the practice of it is just going to be that instead of specifying a single ROI file in here, you specify basically a file per subject, and that's how it's going to work in general. In those cases where you have to specify a different ROI file per subject, you're going to have an option to specify here basically a different file per subject, and then everything else is going to be the same. The actual scripts are going to handle the extracting the data differently from every different subject, and then the rest of the results and the statistics and the display of the results and the saving of that information into the math files is going to work exactly the same way. It's only just basically what I'm working is in adding that ability to have this process that actually computes the ROI level analysis to be able to handle this type of different files per subject. So it knows that it needs to extract the data differently from different places for different subjects.
So here, so in the case of it having like a group ROI file, I would specify like the whole path to that file, like to that nifty.
Right, exactly. So this is an actual ROI file. This is a whole path. And if you need to specify multiple files because you have different files for different regions, then use instead of using this syntax, use the typical MATLAB syntax. So when you know that when you do something like that, I don't know. Let me see. So you would use something like that. So this is an alternative syntax for the, I don't know if you can see this, it's a little small font, right? Can you see this okay?
Yeah.
Okay, so this is basically the same syntax. It's basically when you call the FL function, you just pass parameters to it. When you can pass the parameters when they are strings, the parameters can be passed as different words, basically, as if it was just you can just pass them within the parentheses as different elements of just separated by commas, right? So when you have multiple files, you can enter here what is called a cell array with multiple files. So this would be like something like file one, I don't know, data file1.me, and this would be something like data file2.me. So basically this syntax, you can, and this is already in there, you can actually specify multiple files using this syntax, and it will basically extract any particular one or multiple ROIs that we're defining here, in addition to any one or multiple ROIs that we're defining there, and it will use the combination of all of those ROIs for running the ROI level analysis. Is that okay?
One, I know, one just like good thing question that would be important to know the answer to is when it's calculating the ROIs, is it taking the average of the beta values from the first model, or is it taking the average segment, like time course, and then estimating the model on that time course?
Right, it's doing the former, basically. It's taking the average of the beta of the voxels, beta values for every individual subject, and it's entering that into the second level analysis.
What have we done in the past?
Yeah, in the past we've used both approaches.
Is there an advantage or disadvantage to either of them?
Right, I am hesitant to add the ability to do the latter, so basically to be able to run so basically aggregate at the level of the first level time series, and then do on that aggregated time series, do the first level analysis at the level of the ROIs, and then do take those to the second level analysis, as opposed to this, which is basically doing the time, basically the first level analysis, the time series analysis are done separately for every voxel. And then when you want to do some ROI level analysis, you just aggregate the betas across the voxels. So because for the most part, and there is a little caveat here, but for the most part, the general linear model that is run at the first level analysis is a linear model. And that means that whether you aggregate first and then compute GLM, or whether you compute GLM and then aggregate across voxels, you get exactly the same. But that is not totally true. There is one minor thing which has to do with the estimation of the temporal covariance, which makes those two analysis streams different. Basically, the estimation of the residual maximum likelihood model to approximate tries to approximate the scan-to-scan temporal covariance, the amount of cross correlation in the time series, is going to understand slightly different things whether you do it. Well, it's going to produce it's going to cause that these two ways of doing the analysis will be slightly different. But because it's not exactly clear which one is best, I don't think it's, or at least I'm not convinced that it's worth to having both options, because I don't quite clearly see that one of those will be better than the other one. So, but I can be convinced either way. Right now, the implementation only allows you to do this way, which is basically the first level analysis are run individually for every voxel, and then you do the aggregation of the beta values for every individual subject across the different voxels within the ROI. We could potentially add a different way of running this analysis, which will be doing the aggregation at the level of the time series and then doing the first level analysis on that. But I'm not. What do you think? Have you heard or read anywhere anything that sounds like a convincing evidence that one way is better than the other, or what do you guys think?
I don't know if one way would be better than the other. I think it's fairly straightforward though to interpret the way that you're proposing to do it, which is you estimate the contrast at each voxel, and then the ROI analysis is what's the average response.
Yeah. I mean, and the analyses are almost exactly the same. It's only because of this subtlety of the residual maximum likelihood approach to the temporal covariance that actually produces slightly different things. If you are not modeling temporal covariance, for example, when you have a sparse design that you don't model any type of temporal cross correlation, then the two things will give you exactly the same beta values, exactly the same thing. Whether you do the first level analysis on the aggregated time series or whether you do the aggregation at the level of the beta values, you get exactly the same numbers, exactly to the level of machine precision, right? Mm-hmm. It's only when you do this temporal correlation that introduces slight variation in these measures. But I don't know, or at least I'm not sure whether there is any clear rationale to think of one being better than the other. So
there's sparse acquisition anyway, right?
Yes.
Well, many of our studies are, yes.
Although I've been running my first level with the AR1. Is that the same thing, or is it different? Like the AR1.
AR1 is the typical model that you use when you're having continuous data, basically. And if you have a sparse data, you should use the none for the temporal correlation thing. It's not going to change much because SPM is likely not finding any temporal correlation if your actual sparse acquisition was long enough to remove most of the cross correlation between subsequent scans, right? It's only that you are asking SPM to actually find that correlation when you pretty much know that there is not going to be any. Okay, so and there was another question, another thing that was related to this question, the aggregation, that I think that I wanted to ask you guys, because there is still no option for this, and I think it might be actually useful to have that additional option, but I'm not sure whether it will be or how to put it. So when you specify an ROI file, we are always thinking of these ROI files as basically ones and zeros, right? And you're going to do the aggregation as taking the average across the all of the voxels within the ROI. But in some cases, where, for example, you want to have like probabilistic ROIs, you don't want to do the aggregation like taking the average. You want to do something like a weighted average. And the underlying scripts that are actually run when you run these scripts are actually able to do these weighted averages, use these weighted averages instead of just raw averages. Or they are actually also able to threshold ROIs by a different number than just by 0, right? So right now, if you enter an ROI file that it contains continuous numbers, like positive and negative numbers, the ROI is going to be interpreted as anything that is positive is a 1, and anything that is 0 or negative is a 0. And that is going to, across all of the voxels that have 1s, the ROI, we are going to be computing the average across all of those voxels. But I imagine that there will be scenarios where you might not want to do that, and you want to specify to our scripts that you actually want to use like a weighted average, or you want to use a threshold that is actually not 0. So I don't know, take the values that are available of 0.5, and those are going to be the ones to define my ROI. So do you think this is useful, question one, and how do you think we should basically add that additional information, basically potential thresholds that you want to specify to your ROI file and potential potential option to take the numbers within these ROI files and interpret them as weights for doing weighted average instead of just raw averages. So what do you guys think?
This idea of weighted averages is pretty cool. So we'd have it would be weighted by like the probability that it's actually that structure. Say. Right? Is that that's what you're saying, right?
Right, exactly. You have like a probabilistic atlas where you have numbers that are ranging. Sorry, go ahead.
Yeah, it's like this is 70% likely to be containment, and this other voxel is 3% likely to containment. Then you would weight that. It seems to me that this might be something we should kind of swing back to this as a meeting of itself, because we could do that, say, for the subcortical ones, and maybe there are other. Yeah, I don't like it. It'd only be like right now. We'd have to have our ROIs be a little different. Like we'd have to come up with some new ROIs, basically. I think other than the subcortical ones. So I think it could be useful right out of the gate. That would be the one thing.
So when you're saying subcortical, you're talking about the X-ray ones we talked about, like the probabilistic atlas ones, or are you talking about the PTI?
Talking about the probabilistic atlas.
Right, okay.
So that might be useful. And we have those. I'd have to. So right now I have the ones that are sort of like ready to go are individual binary. They're zeros and ones, but I have all the probability maps, and we could look at those. And we'd have to make some decisions about what the thresholds would be.
I feel we could do something similar with the wage growth that I've already instead of just like making everything that's most likely highest number is to say only take the ones that I actually have from I have not put. But I think we could do some kind of threshold
on a more simple level, or like a practical level, if we could get away from having to, so if you have this like set of like say cortical ROIs or subcortical ROIs or both, and you could, but they're in the same space, so like it'd be like all the volume subcortical cortical ROIs or just the cortical ROIs on the surface. If you could have, you could go by, you could have them all labeled on that surface, and then you just input, okay, here's a link to this labeled surface, and then here's the list of the indices that we want to include in our ROI analysis. That would make things, I think, easier potentially just from a file management standpoint. Because I think right now we have to come up with one file per ROI.
No, you can have an atlas ROI as long as they are not, basically you can enter multiple ROIs within a single file as long as they are not overlapping, right? So you can have like numbers, and ROI file can be defined by numbers basically, and they are integers from 1 to any number, 100 if you have 100 ROIs. And basically every voxel has a number. If it has a 0, it means that it doesn't correspond to any ROI, and if it has a particular number, it means that it corresponds to that particular ROI. And so if it has a voxel that has a 3, basically is going to be aggregated to the third ROI. So every voxel that has a 3 is going to be aggregated as a different ROI. That's what we call what I've been calling basically an atlas ROI. So you can have either a single ROI just has ones and zeros, or an atlas ROI that basically has integer numbers and basically specify multiple ROIs in a single file. The only problem with this type of ROI definitions is that they are categorical, right? A voxel either is or is not in a particular ROI. If you want to have something like a weighted ROI definition, then you want to have like separate files per subject, because it's likely that a given voxel is going to have different weights for different. Well, you can also have, this is going to work as well. In the current implementation, you can also specify a 4D volume. So you can still have a single Nifty file that contains multiple, like a four-dimensional, basically, volume. It contains multiple, like a single Nifty volume that contains all of the time series data. You can also have multiple 3D volumes within a single Nifty file. And each of those individual. So that would be a way to have in a single file multiple ROI definitions that allow overlapping for a particular voxel, right? So a voxel can belong to two different ROIs, which cannot happen if you use the other approach, the type of ROI where you have a voxel that specify the ROI by an index number, right?
With Alfonso, so it's Atlas ROIs, they have to be consecutive numbers, or could you use like what we already have? Say ROI if that number is like 4,000.
Yeah, they can have different. Let me see where I have a good definition for this. I'm using the con structure for all of this. So basically, anything that is accepted by con is also going to be accepted by our FrankLab scripts, basically. And the type of ROIs, there are. Let me see if I find a good place where. Let me see if I can think of it. A good place where I have all of the alternatives. You can have. Well, the short answer is that you can have different numbers that they don't need to be consecutive, but you have to specify one particular way of labeling the data. So typically when you have consecutive numbers, you have two files. For example, let me show you in here actually.
It would be really easy if you could upload just a C tab with all the ROIs and save that.
Right, and yes, it works. This actually accepts the how is it called, the free server annotation files. You can actually enter annotation files as an actual atlas, and you can specify, the how was it called, the LUT text file, basically, that specify the association between that is all accepted by our scripts as well. And that is one way, for example, to use different numbers that are non-consecutive for different ROIs. But the typical case, I don't know, one example of this of Atlas is basically this. You have a file that is called atlas.ni that contains basically numbers, right? So if I do that, let me see. Basically, this has numbers that go from 1 to 100, sorry, from 0 to 132. And then you have also something that is called Atlas text file. So a text file that basically has the same name as the Nifty file and just has the 132 labels, right? And this is a typical Atlas file where the numbers are consecutive. If you want to have something that doesn't have consecutive numbers, you can do exactly the same, but you can have this atlas.ni have numbers that are non-consecutive, only that when you specify this file, you have to, instead of entering one number, just the list of labels, you enter first the number, I don't know, 100, this number corresponds to that label, and then this other number corresponds to that label, and this number, 112, corresponds to that label. So you enter basically pairs of numbers and labels, and that also is a valid Atlas ROI file for our scripts.
Okay, so well,
but yeah, if you have one specific case that you want to make sure that it works, just send me the particular case.
I think that's the next step here. But Elaine has to go. I have to go.
Yeah, me too.
Do you?
Okay. Sorry, I didn't mean to end.
No, well, I think. Well, I have to go. Do you? People, there are a couple people here. If you want to keep going, or we could. I think the key here is to go over some examples.
Yes.
Yeah. Pick NAT analysis, for instance, and just get that going. If you're going to continue to work on that now, that's fine. If not, I would be in favor of meeting again tomorrow.
Let's reconvene tomorrow, because I also have to check on my kids and say.
Okay. I was also wondering if, at the moment, it just feels like there's a big push in the lab amongst all of us to do a lot of this analysis, and this meeting has been insanely informative. But I wonder if we could have a weekly meeting just for possibly the next month.
Yeah,
Because every week we have so many questions, and
yeah, that sounds perfectly fine. We can.
I would even go more aggressive than that if we can. In that,
well, if it's possible, but we
everyone
haven't
needs
had a
this
meeting in
done.
months.
right, and there was a point where we started to do this again, and then it kind of blew up. But Alfonso, would you be able to meet tomorrow?
Yeah, no problem at all. We can do the same.
We have our lab meeting, right?
No, it's on Thursday.
Is it possible to meet? Matt, are you available tomorrow?
And you should run the video already seems to be ended.
Yeah.
Oops, tomorrow, sorry, I say yes to Song. Tomorrow I have a thing in the afternoon, sorry. I could do it in the morning or I could do it Thursday anytime, basically. Do you want to do like early morning before our speech lab meeting, or do you prefer to do it on Thursday?
I could do it in the morning. I can't do it before 10:30. But people can get started if they want to do it earlier. We'd set our meeting at 10. I actually realized that.
Right, I need to, let me see, the time difference is 5 hours. So I need to be off by a little before noon. So I don't know, 9 to 11 or 9:30 to 11:30 could be something that I could do.
Sure.
Or we could leave it for Thursday afternoon, whatever works best for you guys.
We're scanning.
Oh, you're scanning. Oh,
In the morning and in the late afternoon.
And I really just want to get this done.
Yeah.
So why don't you guys meet whenever you can in the morning, and I'll jump in when I can.
Okay.
okay. And do you have any like quick questions that you want to ask now that you might need for right now before kind of wait until tomorrow, or anything else that you have questions?
Sorry. What time did we settle on a time tomorrow? I think I missed that. What time is it? 9 or is it 9:30?
Whatever you prefer. What do you prefer, guys?
9. Either one works for me. So do 9. It's earlier.
9. Okay, perfect.
Great, thank you.
If you want to continue, yeah. If you do, I think Alfonso has to run too, but
yeah, I have to run now also as well. I could meet in an hour or something, but I need to take a break at least for a little bit.
Okay, thank you.
So do you guys prefer to continue a little bit in about an hour, or do you prefer to just wait until tomorrow, or do you have any quick questions, like a 5-minute type of thing that you want to do right now?
Just wait till tomorrow.
Just wait until tomorrow? Okay, sounds good. Okay.
Thank you.
No problem. And if you have any particular questions that you want me to think about it or prepare for tomorrow, just send me an email and I'll do that.
All right.
Yeah, I just want to kind of go through and confirm that each of my second config files is set up properly. So
Right. We can do that tomorrow and just walk through those configuration files and look at the results and make sure that everything looks fine. And that will serve as a good example for everybody as well.
Okay, great.
All right.
Okay. See you guys then.